Hey everyone. It was really good to see some of you in school today. I guess I'm recording this on Wednesday. And this is the Thursday 429 asynchronous work. And we're going to be talking about the engineering design process. All right, so we are now in a new unit. We have finished up before break our physical sciences unit, and that was about, remember, like kinetic energy, potential energy, heat, stuff like that, that is part of physics and chemistry in high school classes. And now we're moving on to our last unit of the year. We're going to be talking about engineering for the rest of the year. This is mostly going to be similar to other units. There's going to be a lot of the videos and questions for asynchronous work. And then during synchronous time, we will do some classwork and then sometimes an engineering challenge. For those engineering challenges, if you're at school, we'll have the materials here for you. If you're at home, it will be either stuff that's like pretty common in houses, like you might need a piece of paper or something like that. Or I will send some materials home. One of the upcoming projects is a bridge building project, and you will need some materials from us for that. So I'll make sure that those get to you. All right, so today we're talking about what are the parts of the process engineers use to solve problems. Please be taking notes on this. You definitely need to write down, especially like engineering, you might have a pretty good idea of what that is already. If you feel like that, you don't necessarily need to write this definition down, but you will need to write down the steps of the engineering design process. So engineering is a repeated process used to create machines, structures, or systems that can make life better. Really important point here is that it's a repeated process. So engineers go through this thing that we call iterative design, where they're trying something out, then making it better, trying it out again, making it better again. So it's really important that this is repeated. It's pretty rare that we solve engineering problems with just one attempt. Think about for a minute, what are some examples of things that engineers have worked on? Try and come up with 3. All right, so you can look around the room that you're in or out your window, and you can very easily find 3 things. Most things that are human-made are engineered in some ways, some more than others. Your laptop has been engineered and redesigned a ton of times. That's something that's definitely engineers have worked on. Even something like a chair, engineers or designers of some sort have done kind of an engineering process on a chair. Let's see, and out the window I can see a building being made. Engineers have definitely worked on that. All right, so the engineering design process is a process that engineers use repeatedly until they have a strong product. So this is really similar to our scientific process. They have a lot of similarities. And one of the important things to remember with each of these processes, we talk about them as if they have like concrete steps. You're about to write down a list of steps that they have. It's really important to remember that these aren't exact things. Like a scientist isn't sitting in their lab pulling out a paper that says scientific process and following each step exactly in order and then calling it a day. And same thing with the engineering design process. You're not just following every step exactly in order and never changing things around, but it's a good way to talk about what engineers are generally doing. So we're going to use this process that you're going to see on the next slide. And in other contexts, you might see the steps being slightly different. I think some engineering design processes are written just as like 6 or 7 steps. We're doing one that has 8 steps. They all have a similar idea, and the important part is that they're repeated until you have a really good product. All right, so make sure you're writing these down. We're going to refer to these for the rest of the quarter or the rest of the unit. The first step is defining the problem. That's pretty similar to the scientific process first step of asking a question. Second step, again, similar to the scientific process, is researching the problem. Third step is brainstorming solutions. Fourth step is choosing the best solution. Fifth step is creating a prototype. Sixth step is testing that prototype. Seventh step is communicating, and 8th step is redesigning. This redesign part especially might come in at any part during the process, right? Maybe you create the prototype and you realize without even testing it that it doesn't work. Then you might jump right into redesigning without going into the testing and the communicating. There's no need for those if you already know that it doesn't work. Or maybe you're brainstorming solutions and then you realize that none of your solutions are going in the right direction. You might jump right to redesign and start over with some more research, or even defining the problem better. So the repetition can come in wherever it needs to come in throughout this process. All right, so make sure you have these written down in your notebook or in your online science journal. And then I want you to just pause this video for a minute and see if you can memorize those 8 steps. I'm not going to ask you to write them out tomorrow in class in a pop quiz or anything, but the more that you practice them, the more easily this stuff will come. So go ahead and pause. Memorize those steps for a few minutes. All right, and once you've spent some time memorizing those steps, you can go ahead and answer the questions that are part of this assignment. All right, and I'll see some of you in person and the rest of you in class online.